Okay. So we're going to go through 6 hypothesis tests, and we're going to look at how we set them up. So just the beginning steps of hypothesis testing. We're going to set them up, and we're going to look at what's happening in the test. And what I expect is by the time we get to the 6th one, it'll make sense and you'll be bored. So that is my goal, to bore you by number 6. Okay. So example 1, the drug Lipitor is meant to reduce cholesterol and LDL cholesterol. In clinical trials, 19 out of 863 patients taking Lipitor daily complained of flu-like symptoms. Suppose it is known that 1.9% of all patients taking competing drugs experience flu-like symptoms. Determine if there is sufficient evidence to conclude that more than 1.9% of Lipitor users experiencing flu-like symptoms as a side effect at the alpha 0.01 level of significance. So what you're seeing in front of you is the first part of the template I designed for you to help you just walk through the question. So you're just going to do each step by step, and you'll see how one flows into the next one. So our first step is to decide what kind of test it is. Is this about a mean or is this about a proportion? That's your first step. So does it say the word mean? Because it's going to if it's a mean test. Or does it have a percent? Because it's going to do that for a proportion. So in this case, you don't read the word mean, but you do have a percent. So it's a proportion test. Second, what are the null and alternative hypotheses, and what is the level of significance? It's about proportion, so we know it's about P. So the first one is P is equal to something, and that's our null hypothesis. And then what do we think is going to happen would be our alternative. So it is known that 1.9% of patients taking competing drugs experience flu-like symptoms. So that's going to be our P, our 1.9%. We're always going to write this as a decimal, 0.019. If you don't write as a decimal, it messes up later in StatCrunch. So now as we read through, we want to see if there's sufficient evidence to conclude that more than 1.9% experience the symptoms. So this will be a greater than test. And notice the number is exactly the same for H1 and H0. And then we just look for alpha for our significance level. So the reason I set it up this way is now all you have to look at is this to finish the problem. It's all set up for you. And you don't have to go back into the words, which can be very confusing. So now we pick out the sample data information. We don't need the mean side, we just need the proportion side. And we're looking for our sample information. So if we go back, it said the clinical trials, 19 out of 863 patients complained of flu-like symptoms. So our X will be 18 and our N samples, 19. I read that wrong, 19. And our N is going to be 863. All right, so there's your sample data. Now for this part of the problem, I want to stop and just set it up like this and think about what's happening. So I've asked you to draw a sketch of the sampling distribution and label the mean and sample statistic and shade the p-value. And then write the probability statement we're talking about. So first thing I want to do is find that sample statistic p-hat. P-hat is 19 divided by 863. And that's equal to 0.022. So we're looking at a sampling distribution for p-hat. We have mu sub p hat here. And that's our original mean of 0.019 from the problem. Now our sample is over here to the right because it's 0.022. That's our p hat. Over here, that's a 0.022. And our p-value is this shaded area. This shaded area is our p-value. Any question? So what is the probability statement we're looking at here? We want to know the probability that our p hat being 0.022 is extreme enough. So greater than or equal to 0.022, we want to know about that probability. That's our p-value. And we want to compare that to alpha. Is it greater than alpha or not? And our alpha is 0.01. So this is our probability statement that I'm talking about. So what's happening is we have this distribution, we have our mean of 0.019, we took our sample, 0.022, and we're saying, is that far enough away from 0.019 that we can really say there was a change? So to say if it's far enough away says, what is the probability it could happen? And that's what this statement is. Any questions?
Where does StatCrunch come with this?
StatCrunch comes next, and we're going to do that in the second part. We're just going to set each one up now to understand the setup, and then we'll go through with StatCrunch the full thing later.
Okay.
Okay. Okay, number 2.